those problems in the packet that I gave you guys on sometime during Regents review. So it was a big packet. It had 2 Regents exams stapled together. If you don't have it, it's just the June 2013-2014 Regents. So you can get it online, just so you're aware. All right, so we are going to work through that packet, which again are the June 2013-2014 Regents exams. We're probably just going to do the June 2013 multiple choice today. But if you don't have the packet, you can just find it online. All right, so I'll get started in a minute. Let me get the link out here on Remind. Working through those packet questions. If you have the packet, this should be the first question. If you don't have the packet, no big deal. Again, it is just the June 2013 Regents we're going to start with. The first 85 questions in that packet are from that school year. Then the next 85 questions are from the June 2014 Regents. So basically, we've done every June Regents exam since 2013. So your review book had 2015 through 2018. And then this packet has 2013 and 2014. So I'm going to get started. I don't expect too many people to be checking in just because it's Saturday afternoon. But again, I always post these on my YouTube channel, and I'll send that link out when I'm done. So, June 2013 Chemistry Regents, question 1. Here we go. We're going to get through the multiple choice today. Tomorrow at 2, I'll do the short answer. And then tomorrow at 7, since I imagine tomorrow and Monday night will be a popular one. But tomorrow at 7, I'm going to do like the top 20 to 30 most popular Regents questions. So I'm literally going to go through every Regents exam from 2013 to 2018, all the June ones, and look at all the ones that repeat year to year to year to year to year. So you can just nail those questions on Tuesday. So, question 1. According to the wave mechanical model of an atom, an orbital, there's the key word, is a region of the most probable location of what? That would be an electron. Proton is going to be in the nucleus. The other 2 answers, 1 and 2, alpha particles and gamma rays, are types of particles that are released during nuclear decay. So you hear orbital, you read orbital, you think electron. Orbital is definitely a word in that Quizlet that of the top 50 vocabulary words to get you through the chemistry Regents. That's on my course website. I'm going to send a link out to that on Remind tomorrow. Which particles have approximately the same mass? Now, you could, based on all the ones listed besides the electron, which is kind of on Table O, but you could just look these up on Table O. So if you look at Table O, I believe alpha, proton, and neutron were all answer choices. Beta particle kind of simulates what an electron is. They're not like quite the same. They don't have like the same background. But E, you can think of as electron. Its charge is -1, and electrons, in fact, have no mass. So you can kind of treat it like an electron. It gets a little confusing, though, because positron also uses the symbol E, so you just have to be careful. Alpha particles have a mass of 4. Remember, it's the top number, that's the mass. Neutrons have a mass of 1, and protons have a mass of 1. So the correct answer is, if you didn't memorize it, same mass, proton and neutron. During a flame test, a lithium salt produces a characteristic red flame. This red color is produced when electrons excited lithium atoms. This one I know for a fact I'm going to go over again tomorrow because it's a constant asked question, whether it be multiple choice or short answer. It's all about the electrons moving to a lower energy state. So it goes from excited to ground. Be careful with 1 and 2. When you lose or gain electrons, that's not what leads to the color. That's going to form an ion. So when you lose electrons, like in answer choice 1, you're going to be a positive ion. And when you gain electrons, you're going to be negative ions. And that happens because electrons are negatively charged. 4. Compared to the energy and charge of the electrons in the first shell of a Be atom, the electrons in the second shell of this atom have. So the fact that it says Be, which is beryllium, doesn't really make a difference in answering this question. You're basically comparing the energy of a second shell electron versus the energy of a first shell electron. First, give yourself the best way to answer this question. Give yourself the best chance to get it right, I should say. If you're comparing electrons, they're always going to have the same charge. So you want to eliminate the two answers that say they'll have different charges because electrons are always negatively charged. The second shell, since it's higher than the first shell, it's further away from the nucleus, is going to have more energy. 5. Which quantity can vary among atoms of the same element? So, this one was a little tricky. You want to cross out 2 and 3 because that's the same thing. Protons and atomic number both identify what the element is. If an element has 8 protons, that element's atomic number is 8, and we would say that's oxygen. If you change the number of protons, you're going to change the element. The question says we want to keep the element the same. Now, you might look at answers 1 and 4 and think they are both right because you can change the number of electrons and keep the same element, and you can change the neutrons and therefore change the mass and therefore change the element. Keep the element the same. But it wants to make sure it stays an atom. When you change the number of electrons, that becomes an ion, which means it's going to have a charge. An atom has no charge. So the question was saying, how can we keep the element the same, keep the charge 0, but what can change within that element? And the answer would be the mass number. When you change the mass number of an element, you have what's called an isotope. Isotopes are same protons, different neutrons. 6. Which substances have atoms of the same element but different molecular structures? What an odd question. Obviously, the right answer is 2. It's the only one that has the same atoms. 1 is helium and neon, 3 is potassium and sodium, and 4 is phosphorus and sulfur. I'm not sure how anyone would get that question wrong. 7. An atom that has 13 protons and 15 neutrons is an isotope of the element. This is basically a roundabout way of asking, can you go to the periodic table and look up who atomic number 13 is? And atomic number 13, that I have X'd out right there, is aluminum. So, the right answer is aluminum. Another kind of gimme question. Which elements have the most similar chemical properties? This is a question that I like a lot. Most similar chemical properties mean same valence electrons. And the same valence electrons are going to be atoms that are in the same group. Because when you look at the periodic table, atoms in the same group all have the same number of valence electrons. So all of group 13 has 3 valence electrons. So let's go back to the answer choices. We've got Si, As, and Te. Let's see. Si is in group 14, As is in group 15, and Te is in group 16. So I think the key reason they put that answer choice there was because they're all metalloids. They were like, oh, they're all metalloids, they must be similar. That's not what they're looking for. All right, what's another answer choice? Mg, Sr, and Ba. There's Mg, Sr, Ba. All have 2 valence electrons. They're all in the same group. Therefore, they have similar chemical properties. So, there we go. 9. Which list includes 3 types of chemical formulas for organic compounds? So, keep in mind, organic compounds mean they contain carbon. So we want to see which ones would make sense to have carbon in it. So I'm going to cross out 1 and 2 because they say metallic. And while organometallic uh, compounds exist, they're not really part of the curriculum, so I don't think they're trying to trick you here. What you can have with organic compounds is an empirical formula, because remember, this is talking about formula. So again, isotopes aren't really a formula. Like, they're just saying we have the same structure, but the same atom, but a different mass. So we're not getting a formula out of it. You can have an empirical formula like CH4. You can have a molecular formula like C2H8, which I've reduced to CH4. So empirical just means reduced. And you can have a structural formula, so I could draw out CH4. So the right answer here was 4. The key word there was formulas. 10. In a bond between an atom of carbon and an atom of fluorine, the fluorine atom... so let's do 3 and 4 first, because 3 and 4 would be the easiest to check. 3, a smaller number of first shell electrons, or 4, a larger number of first shell electrons. If I look at fluorine, fluorine has 2 in the first shell, and carbon also has 2 in the first shell. So I'm going to cross out those because they're both the same. Now, a weak attraction for electrons is just a fancy way of saying which one of these has the higher or lower electronegativity. Electronegativity is another vocab word I put in that Quizlet that I'm sending out to you guys. So it's a good thing to look that up. This is going to be another question we go over tomorrow of the most popular types of questions that they answer or ask. So we are concerned about the fluorine atom. So let's look up fluorine and carbon's electronegativity. Let me erase some of these since I've done this a bunch. We got fluorine at 4, and we got carbon at 2.6. Since fluorine's is higher, we would say fluorine has the stronger attraction, but let's make sure we answer the question right. So it's asking about fluorine, got it. Fluorine has a stronger attraction, got it. A sample of CO2 solid and a sample of CO2 gas differ in their chemical compositions is going to be no, because it's both a carbon with 2 oxygens attached to it. You can't reduce either of these more than that. CO2 is the most simplified form, so their empirical formulas are the same. Molecular structures. So I'm going to draw carbon dioxide like this every time, regardless of what state of matter it's in, because it's carbon dioxide. So no. Physical properties, though, are going to be different because they are 2 different states of matter. One is a solid and one is a gas. And solids and gases have slightly different physical properties. Solids are more like ordered. They have a lot less entropy for them. They are more crystalline in their structure. Versus a gas has more disorder. Therefore, a lot of entropy, tend to be moving a lot of more unpredictably, might have a different density, etc. 12. Which statement defines the temperature of a sample of matter? This is just a straight up memorizing question. Temperature is the same as kinetic energy, more specifically the average kinetic energy. So if one of those answer choices in 1 or 2 said total kinetic energy, that would not be correct. Temperature is the same as the average kinetic energy, which is answer choice 4. For a chemical reaction, the difference between the potential energy of the products and the potential energy of the reactants is equal to the, again, this is another memorizing question. Heat of fusion is the energy required to melt a substance. The heat of the reaction would be the correct answer. The activation energy is the energy required to begin the reaction. So when you think of those funky diagrams that look like this, the activation energy is subtracting the peak of the hill from the energy of the reactants. Which equation represents sublimation? Sublimation is when a solid turns directly into a gas, kind of missing that liquid phase. So that's going to be 2. 1 is freezing, 3 is condensing, and 4 is vaporizing. Which statement describes the particles of an ideal gas based on the kinetic molecular theory? I'm going to go through every answer choice because it's helpful to remember what those principles were based on the wrong answers. 1, the motion of the gas is disorderly and straight lines. So usually we say random straight line motion. So no. 2, the gas particles have no attractive forces. That's going to be the correct answer. 3, the gas particles are smaller than the distances separating them. And as the particles collide, the total energy of the system decreases. We want to say when they collide, they transfer energy. The energy is not going to disappear. You can't decrease or really increase the energy we have. It's just going to transfer from particle to particle. So, no. 16, 2 grams of potassium chloride are completely dissolved. Keyword there. This solution is classified as, so first, as soon as it says dissolved, that means we got a mixture. We are not forming a new element out of this. The water and the potassium chloride are not reacting, so we're not getting a compound out of this. And it says it's dissolved, so it's not a heterogeneous mixture. Therefore, we are homogeneous. Which compound has the strongest hydrogen bonding between its molecules? So this may seem initially confusing at first because you look at it and you say, well, H is involved in every compound here. How in the world can they not all be hydrogen bonding? Because hydrogen bonding is not this bond. Hydrogen bonding is the attractive force between an H and an F, O, or N. So hydrogen bonding is Fon, and it occurs between the molecules. I think it would be more accurate to say a hydrogen force, because that's really what it is, because it's an intermolecular force. I don't know why they call them hydrogen bonds, but either way, just remember that they're Fon, F-O-N. 18. Powdered sulfur is yellow and powdered iron is gray. When powdered sulfur and powdered iron are mixed at 20 degrees Celsius, the powdered iron, so it says mix, and it doesn't give you any indication that they're reacting chemically, so you can't just say that it's going to change in any way. So the iron is not going to magically become yellow, because that's the color of the sulfur. The iron itself is alone, therefore it has metallic bonding. If it said they were reacting chemically, it might turn into an ionic bond, but it didn't say that anywhere. So it's not going to remain ionic because it wasn't ionic to begin with, it was metallic. Becomes a liquid. You could always look up the melting point of iron on table S, see what it is. You can convert that to Kelvin by adding 273 and see if iron's melting point is below 293 Kelvin. But you might reasonably conclude that it doesn't because iron is everywhere and it doesn't exist as a liquid state. Because what's true is it's going to remain magnetic. As long as these things don't react chemically, which they're not here, they're going to retain their properties, and iron is going to therefore remain magnetic. Again, if you want to double check that iron didn't melt, we can look up its melting point on table S, and it melts at, that's not melting point, it melts at 1800 degrees, which it definitely did not do. Okay, got a question on Remind? All right, which would have the strongest IMFs if Fon was not a choice? So let's say you had HN, HO, and HF all as options. You would want to choose HF because HF is the most polar bond. So the strongest IMF is going to exist between the most polar bonds. And to determine how polar a bond is, again, we're talking a bond here, not molecule. You want to look at how far apart their electronegativities are. The further apart they are, the more polar it is. So since F is at 4, oxygen's at 3.4, and nitrogen's at 3, the bond between a fluorine and a hydrogen would be the most polar and therefore be the strongest intermolecular force. I don't know if you'll see a question like that, but it's a good question. Okay. 19, and this is another memorizing one. You're going to notice a lot of the first 30 are like really quick. I see the key word, I pick the right answer. I see the key word, I pick the right answer. An effective collision requires that particles have the correct energy and orientation. And I'm pretty sure this came up in the June 2018 one because I remember talking about it on my live streams last week. Think about like the analogy I use is trying to put your key into the ignition of your car to turn it on. If the key's facing the wrong way, no matter how much energy I try, the key's not going to go into the ignition. So that's orientation. Or if I have the key facing the correct way, but I'm trying to force it in at such a slow, lazy amount of energy, and then try to turn it really slow, it's not going to start. So, energy and orientation. Which term is defined as a measure of the disorder of a system? Entropy. These three in a row, really quick. Which process is used to determine the concentration of an acid? You could, flip around the reference table if you don't remember this word. The titration equation has molarity and volume of acid in the formula, and molarity is concentration. Therefore, you could quickly say that it's titration. Chromatography is based on the polarities of molecules. So when you think chromatography, you think polarity. Distillation is all about boiling point. And electrolysis is all about electrically separating something. We talk about it with electrolytic cells, and that's when we take electrical energy and convert it into chemical energy. The compounds CH3OCH3, so methyl ether, and ethanol have different functional groups. Therefore, these compounds have different properties. Different things are different. If they have different structures, they will have different properties. Why are the other ones wrong? Because again, you can kind of figure this out by process of elimination. Gram formula mass means how much does this compound weigh based on the atomic masses of all the atoms? Well, these both have the same formula. They're both C2H6O. So their masses are going to be the same. Therefore, the percent composition will be the same because their masses are the same and the number of atoms are the same. And I just said number 4. So, 1. Which term identifies the half reaction that occurs at the anode? So, red cat, anox. Anode is oxidation. 24. During the operation, not process, of a voltaic cell, the cell produces. So usually they give you like the answer choices as like this to this, this to this. This one just wants to know what it makes at the end. So voltaic cells are all about chemical to electrical energy. So we're making electrical energy. Gone. Spontaneously. What does spontaneously mean? The only time I think a lot of students have heard the word spontaneous before is with spontaneous combustion. Spontaneous just means as soon as you set up the cell, the reaction is going to go. You don't really need any outside energy source. You just connect the two electrodes together and they're going to chemically produce energy. Well, they're going to convert chemical energy, I should say, into electrical energy. And that spontaneity is based on table J. So, if you were to hook up, let's say, zinc and magnesium is higher, so it would get oxidized. Zinc is lower, and it would be reduced. And, you set up your salt bridge, you connect these two pieces of metal with a wire. The electrons are just going to spontaneously go from anode to cathode with no input from you. All you needed to do was get these two chemicals to start interacting with each other. So spontaneous is like when you did a lab and it just started bubbling. You didn't put it on a hot plate. You didn't really even have to stir it. You just took a piece of zinc, put it in some hydrochloric acid, and boom, it went. That's spontaneous. 25. In which type of chemical reaction are electrons transferred? So that kind of just plays along into the question we just did. So this is like Leo says Gur. Lose electrons, oxidation. Gain electrons, reduction. So the electrons are being lost from one thing and given to the other. So that's oxidation and reduction. Ooh, text message. Does the anode or cathode lose mass? So in a spontaneous voltaic cell, the anode will always lose mass. And that's not because it's losing electrons. The losing electrons is part of it, but the reason is not because it's losing electrons. It's because that solid chunk of metal, let's say magnesium we did in the previous example, is turning into a magnesium ion as it loses electrons, and those ions leave the solid chunk and go into the solution. So the anode's always going to lose mass, and the cathode's always going to gain mass. And the cathode's going to gain mass for the opposite reason. Those ions in solution are going to turn into atoms, and therefore the electrode will gain mass as a result of the ion becoming an atom. So the anode always loses mass, and the cathode always gains mass. Hold on, I think I got another text. Nope, okay. 26. A substance that dissolves in water and produces hydronium ions. As soon as I see that, I'm going acid. So, hydronium ions are H3O+. You can look that up on table E if you didn't know what hydronium was. It'll be there. And it's a quick one to find. It's like one of the first three. I think it's the third one down from the top. So, hydronium, acid, hydroxide, base. Hydronium, acid, hydroxide, base. According to one acid-base theory, a base, no, so that's a quick one. So acids and bases in a chemical reaction either donate H's, specifically H+, or accept H+. And the acronym for this is BAD. Bases accept, acids donate. Bases accept, acids donate. Which compound is an electrolyte? So, you're looking for two things here, three things here. An acid, a base, or an ionic compound. So, something from table K, something from table L, or some compound with a metal in it. When I look at answer choices 1, 2, and 3, carbon and chlorine. Carbon and chlorine. No. There we go. Carbon, non-metal. I remember seeing oxygen, non-metal. Chlorine, non-metal. So remember, everything to the right of that staircase is a non-metal. Don't forget hydrogen. Hydrogen is also a non-metal. So be careful. Since I remember seeing all of those in the question, non-metals, 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 non-metals. Calcium, that's a metal. CaOH2 is also on table L because it's a base. So that was kind of a gimme. No excuse to get this one wrong. Which term identifies a type of nuclear reaction? Fermentation is organic. Reduction is reduction. Deposition is when a substance goes from a gas directly to a solid. So that's a physical change. Fission, nuclear. Which radioisotopes have the same decay mode and half-lives greater than 1 hour? Well, this is going to be annoying. So I got to go to table N and start looking up all these ones, see which ones have the same decay mode, and if they do have the decay mode, double check that their half-lives are greater than 1 hour. Go me. So let's do the first one. gold 198, and nitrogen 16. So, gold 198 has a decay mode of beta, and nitrogen 16 has a decay mode of beta, so that checks that. But nitrogen 16's half-life is 7 seconds. Nope, not that one. Gotta go back. What a stupid question. Okay, calcium 37 and iron 53. Calcium 57, beta plus, but its half-life is 182 milliseconds, so I'm not even going to bother looking at the other one, because I already know that's wrong. Iodine 131 and P32. 8 days, okay. Beta, okay. 14 days, alright. Beta. That must be the right answer. Congratulations, you know how to read. Alright, so that wraps up the first 30. I'm going to get into the last 20, which tend to be a bit harder. They are less about, like, this is that, this is that, this is that. And they get a little bit more involved. So, let's do this. Which element is not present in the mixture? So you got to make sure you read this right. You want to read it from the top down, not the bottom up. Every single line from the element needs to be in the mixture. Some elements may have the same lines. That's fine. But if the element's line isn't in there, it's not in the mixture. All right, I'm going to do Z first because Z only has 2 lines. Z looks good. All right, let's do X. X is the right answer. So, and over here as well, that's not in there. And these two are also not in there. Okay, X is definitely not in the mixture. I'm done. Yay. What is the overall charge of an ion? So, charge, ion. Who cares about neutrons? Neutrons only make a difference in the mass. Neutrons are not charged. Neutrons are neutral. So, ignore neutrons. Get that out of here. That has 12 protons and 10 electrons. So, electrons are negative, protons are positive. I have 2 more positives than I do negatives. Therefore, my charge is 2+. You can see why they put the 4s, because they thought you were going to compare neutrons and electrons. That's a little trap. As the elements in period 3, they freaking love period 3. I don't know what's so great about period 3. They ask about it constantly. Or in order of increasing atomic number, there is a general decrease in blank. So, you can look up all of these on table S. Atomic mass we can get from the periodic table. I'm just going to tell you right now, you go to the periodic table, and generally speaking, the mass is always going to be increasing as you go from left to right across a period. So I'm just going to cross that one out right away. I know the right answer is going to be radius, just because I have the trends memorized, but how can you use table S to answer this question? So I usually recommend picking 2 elements from period 3 that are relatively far apart from each other, and don't pick one from group 18. I usually say pick the one in groups 1 and 17. Just because group 18 elements don't have electronegativities, they're just a dashed line on table S, and then you get a little confused. So let's try not to use group 18 when you're doing these like trends questions, and just use group 1 and group 17. So group 1, sodium. Why did I get out of here? Let's go back. Sodium and chlorine. Let's look at their electronegativity, their atomic radii, and their first ionization energy. Sodium, we got 496, 0.9, and 160. Chlorine, 1251, 3.2, and 100. The only one that went down was radius. So I was right. Go chemistry teacher. All right, which electron configuration represents the electrons of a sulfur atom? Sulfur is S in an excited state. If you don't remember what the atomic symbols are, like the names for the atomic symbols. You can also look that up on table S. So never like accidentally say sodium is S or that phosphorus or that potassium is P. You can look it up. So like, don't be silly. So sulfur, let's look up its ground state first. Its ground state is 286. 286. So excited state means I need to keep the total amount of electrons the same. So 2 plus 8 plus 6 is 16. But I just need to take one from a lower level and move it to a higher level. That's what excited state means. So 2 plus 6 plus 6, that's what? 12 plus 6? No, not 12. That's 6 times 2. That's 8 plus 6, which is 14. So that can't be it. 2 plus 8 plus 4 is also 14. So that can't be it. 286 was the ground state. So no. This is the right answer. Why? Because it took 1 from there and moved it up. Excited. Given the word equation, which type of chemical reaction is represented by this equation? So we have a compound here. We have one compound here, splitting into two things over here, 1 and 1. So when stuff splits, you have decomposition. Synthesis would be, if the reaction in reverse, would be synthesis, because that's combining things. And then single and double replacement is involving atoms and compounds exchanging atoms with each other. So single replacement would be A plus BC makes AC plus B. So we had a single switch. And double replacement would be AV plus CD makes AC plus BD. So we had a double switch. Whoop, whoop. So that's single and double replacement. Synthesis would be the opposite of the answer given, two things becoming one thing. Decomposition is one thing becoming multiple things. Which compound has the highest percent composition by mass of strontium? Now, this presents itself as a real pain in the butt question because it makes it seem that you got to look up the percent by mass formula, which is mass of part over mass of whole times 100. So in this case, the mass of strontium divided by the mass of the compound times 100. And we want to see which one of those would be the highest number. And while that looks like what you have to do and you can confirm your answer, you want to pick the compound where the atom strontium is bonded to has the least mass. Because the less mass the other guy is, the more of the total strontium is. So we can look up all these masses on the periodic table. So oxygen on the PT, sulfur on the PT, chlorine, and iodine. So iodine weighs 127, chlorine is 35, sulfur is 32, and oxygen is 16. So I was just looking up their masses. So we got 127 times 2, 35 times 2, 32, 16. Strontium weighs 80, let's say 88. So SR is 88. So the formula that's going to be the highest percent by mass of strontium is going to be 3, because the total mass of answer choice 3 is 88 plus 16, where strontium is clearly the vast majority of that mass, versus the other ones have relatively heavy elements, so the percent by mass of strontium is a bit less. Again, if you want, you can calculate all of these percent by mass and just confirm your right answer. I just did it the quick way because I want to save time, not waste a lot of energy. Given the formula for hydrazine, how many pairs of electrons are shared how many pairs of electrons are shared between the two nitrogen atoms. So right there, we got one bond, which means two electrons, which means one pair. One pair. It's interesting that they word it as how many pairs. You would think they would do this to kind of cover them. Interesting. Anyway, which formulas represent one ionic compound and one molecular compound? So we're looking for a compound with a metal and a nonmetal, and another compound that's just nonmetals. No metal, no metal, 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 nonmetal, 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 ionic, molecular. Again, I might have done that relatively fast for some of you. You might need to flip to the periodic table to confirm that. Feel free to confirm my right answer. I know my metals and nonmetals. You might not. No big deal. Which Kelvin temperature is equal to 200 degrees Celsius? So there's a formula for that. Kelvin equals Celsius plus 273. So Kelvin equals Celsius plus 273. So we have 200 degrees Celsius. We add that to 273, and we get the answer of 473. That's not too bad. A 10-gram sample of water at 23 degrees. Ooh, tricky one. Final temperature. Ouch. So this presents itself as kind of hard because of the algebra. But it's multiple choice. You can plug all the numbers in until you get the right answer. Anyway, how do I know what equation to use? I see heat. I see a temperature change. I say Q equals MCAT. Q equals MC delta T. So there's three equations that have heat involved. Q is heat. Don't forget, when you have these equations, they literally tell you what each variable means, so there's no excuse for you to not know any variable in the equation. Where do we get C? C is all the way on the front of the reference table. So we got HF here, we got HV here, and we got C there. So when you're using these heat equations and it's like HF, HV, and C, and you're like, how do I know what those are? I didn't give it to me in the problem. What the heck? You can look it up. So when you look at the reference table, they're all the way at the front. C for water is 4.18. So let's set up this equation. We got 209 joules of heat, Q is heat, equals a 10-gram sample, M is mass, times 4.18. I'm going to rewrite this. No, don't cut. So 209 equals 10 times 4.18 times delta T, which is final minus initial. So our final is unknown, but our initial is 23. So right off the bat, the algebra seems a little bit tricky. And it kind of is, because it's easy to make a silly mistake. But what you could do is plug in each of these numbers for x and see which one equals 209 when you multiply them all together. Another thing you can realize is that since it's asking for the final temperature and it absorbed heat, if it's absorbing heat, the temperature should be going up. So no and no, because those are temperatures going down. So use the problem to help answer the problem. If you do this algebraically, just to go over that, what I recommend doing is not factoring, because factoring can lead to silly mistakes. I would do 10 times 4.18 and then divide both sides by what that is. So you're going to end up dividing both sides by 41.8. That'll cancel out over here. 209 divided by 41.8 is 5. So we get 5 equals x minus 23. Then just add 23 to both sides, and you'll get 28. So there's a few ways to combat this one. How often do I see a final temperature question? Pretty rare. I can almost guarantee this is a highly missed question that year. I don't have the data for it. But if I'm relatively good with numbers, I can get rid of 1 and 2 because, again, if I read this problem from the beginning, it said it was absorbing heat, all right? And we're looking for the final temperature. So we got absorbing heat, final temperature, which means our final answer needs to be higher than 23. Realistically, if I'm doing 10 times 4 times a number, 50 degrees was way too high. 50 minus 23 is pretty darn close to 30, and 30 times 10 is already 300. So use your number sense if you can. If not, solve it algebraically. Ooh, a shifting question. When the concentration of chlorine is increased, all right, right off the bat, I don't even care what the rest of the question says. An increase in a substance will shift away from the increase. So increase in substance, shift away. So that means we're shifting to the left, and this is going to increase because of that shift. Increase a substance, shift away from it, increase the other side. So it's kind of like a, I don't know, if we want to say a seesaw or a scale. If chlorine is, I don't know which way it would be. Let's just pretend it's over here. If chlorine's over here, all right, there's chlorine. I've increased it. I need to increase the other side to get it back to equilibrium. But when I increase this side's going to go down. So you shift away from the increase and you increase the opposite side as you decrease the side that was increased to begin with. It's a lot of words. Anyway, when you increase the substance, you shift away from it. When you shift away from it, you increase the opposite side. So I need to get rid of answer choices that say AgCl is decreasing. Okay. Now, the first part of the question was saying, what's going on with silver? In order for me to even make AgCl, I need to combine chlorine and silver. As I'm combining chlorine and silver, let's pretend this is chlorine and silver, and I combine them, well, chlorine and silver just went away. Here they are, and they're gone. Here they are, and they're gone. That means that silver and chlorine are going down because they need to decrease in order to make AgCl. They need to react to make AgCl. So silver is going to go down as AgCl increases. Whew, no one likes shifting. Okay. Which particle diagram represents a sample of matter that cannot be broken down by chemical means? That means we are looking for an element. So this is what I mean by these next 20 multiple choice are a bit more involved. They're not just asking you to pick an element. They want to make sure you understand that the question is asking you to pick an element and that you understand particle diagrams. So these are like two-part kind of questions. Like 36, did you have to use the formula? Did you know to look up their masses? 37, do you know the difference between a bond and a pair and the total amount of electrons? 38, do you know the difference between ionic and molecular? 39 was kind of straightforward. 40, a lot of algebra. 41, shifting. And not only do they ask you to figure out the shift, but they ask you to figure out what's going on both sides. So, luckily this one's kind of easy. Clearly that's the only one that's an element because it's not bonded to anything. But let's go over the other ones and why they're wrong. So everything in answer choice 1 is a compound because it's two different atoms bonded together and they're all the same compound. They're all black, white, black, white, black, white, black, white. So no. 3 is also a compound and they all kind of look like water. So again, they're two different atoms bonded together and they're all the same. So no. And then 2 is a mixture of compounds because we have this compound here and these compounds. Kind of looks like something mixed with water, so no. So answer choice 4, only element. They love unsaturated. Which formula represents an unsaturated, let's do this first, hydrocarbon. Hydrocarbon means H and C only. Whoa, no, whoa, no. So hydrocarbon does not mean water and carbon. Hydrocarbon means hydrogen and carbon. So what does unsaturated mean? Unsaturated means we have a double or triple bond somewhere in the formula, which is answer choice 2. Answer choice 1, since that carbon-carbon bond is a single bond, that would be saturated. When the pH of a solution is changed from 4 to 3, the hydronium concentration of the solution is... So, we got a substance becoming more acidic because the pH went down. And as the pH goes down, the hydronium concentration goes up. So as the pH goes down, the hydronium concentration goes up. For every step down in pH, I should say it this way. For every 1 step change in pH, there is a 10 times change in hydronium. So as the pH changes by 1, the hydronium changes by powers of 10. Since this only went down 1 step, the hydronium concentration will increase by 1 factor of 10. If it went from 4 to 2, it would increase by a factor of 100, 4 to 1, 1,000, etc. 3 samples of the same solution are tested, each with a different indicator. These should be gimme questions. All 3 indicators of bromethymol blue, bromcresol green, and thymol blue will appear blue if... Okay, let's go to table M. All right. Table M. So we were looking at bromethymol blue, thymol blue, and bromcresol green. And we wanted each of them to be blue. Blue, blue, blue. Which means at the very least, bromcresol green is blue above 5.4. Bromethymol blue is blue at 7.6 or higher. And thymol blue is blue at 9.6 or higher. So for all of them to be blue, the pH of the solution has to at least be 9.6. Boom. As soon as you see the word neutralize, you see a base. You see, I didn't want to erase that or cross it out. You see a base. You see an acid. You see neutralized. You're using the titration formula. So the titration formula, we kind of looked at it before, is MAVA equals MBVB. Titration, MAVA equals MBVB, where A stands for acid, B stands for base, M and V are molarity and volume, respectively. So, we got a 10 milliliter sample of NaOH, that's VB, because that's the volume of our base, is neutralized by 40 milliliters of 0.5 molar HCl, VA, MA. What is the molarity, MB, of the base? So we got MB times 10 equals 0.5 times 40. Multiply 0.5 and 40 together and then divide both sides by 10 and you'll get 2. Not too bad. Watch your algebra, watch your setup, read the question carefully. Don't be silly. You know the drill. Don't goof it up. 2. All right. Radiation is spontaneously emitted from hydrogen-3 nuclei, but radiation is not spontaneously emitted from hydrogen-1 or hydrogen-2 nuclei. Which ones are stable? Well, the ones that aren't spontaneously emitting radiation are probably the ones that are stable. So, boom. If something is just radiating stuff spontaneously, I would not say that's stable. Which nuclide is represented by X? So this is like a two-part thing. First, you want to divide this in half by the arrow. Second, you want to say that the numbers on both sides, the mass and the charge, need to stay the same. Because everything that's conserved in a chemical reaction is CEM. Charge, energy, mass. So TH weighs 232. We got 4 already over here. So the mass of X must be 228 because 228 plus 4 is 232. All right. Nope, because that says 236. Nope, because that says 236. That's nice. The charge of thorium, aka how many protons does it have, is 90. Helium is 2, so the charge of X must be 88. These both have the same numbers. How do I pick the right answer? Well, you go to the periodic table and you pick the answer that has 88 protons, which is Ra. So the right answer was Ra. After decaying for 48 hours, 1/16 of the original mass of a radioisotope sample remained unchanged. What is the half-life of this isotope? So this has gone through a series of half-lives, meaning a series of divisions by 2 from its whole amount to its 16th. So we started at 1 and we divided by 2 and divided by 2. So we got a quarter, divided by 2, eighth, and divided by 2 to get to a 16th. That's a total of 1, 2, 3, 4 half-lives. So it took 4 total divisions by 2 to get to a 16th. That entire thing took 48 hours. So beginning to end took 48 hours. What was the length of each step? AKA, what is the length of one half-life? So 4 half-lives in 48 hours means each half-life was 12 hours long. So 12, 12, 24, 36, 48. I apologize, it got a little bit jumbled there. But if you start at 1 and divide by 2 4 times, you get to 1/16. Since that all took 48 hours, each step must have taken 12 hours. Last question. Which one represents nuclear fusion? So, first, fusion means we are combining nuclei, typically light nuclei. Nuclear means the atoms on the left side are going to be different than the atoms on the right side. So, this is fission because it took a lithium atom and split it into 2 smaller atoms, 2 lighter atoms. Everything else combines things together, but you see calcium, oxygen, carbon over here, calcium, carbon, and oxygen over there. That's not nuclear. Hydrogen and oxygen over here, hydrogen and oxygen over there. That's also not nuclear. Answer choice 1 combines 2 hydrogens and then gets this crazy helium out of it. Where'd that come from? That must be the nuclear one. So, that's it for today. I'm going to do the short answers tomorrow at around 2. And then at 7, I'm going to go over the most popular questions that they love to ask year to year to year. Thanks for watching, everybody. I'll post this on my YouTube channel later. Have a great weekend.